everyone, welcome back to WsCube. In our previous session, we discussed what are modules in Python. Today, we will be discussing about some inbuilt modules in Python. So, guys, there are many inbuilt, there are hundreds of inbuilt modules in Python. We will be discussing few of them which we generally use in our programs. So, we have over here date, time, random, math. Guys, date time allow us to access to know the date and time of any time zone or of any area or of any year. If you're going to, let's say, if you want to check the details of any date which is from the past or from the future, you can check the details of that date, like regarding the day, regarding the time, regarding the year and everything. Random over here, random allows us to randomly get the values from numbers or from the values that we have provided to it. Math over here provides us with so many applications in Python.
Before that, if you want to become a successful data analyst and if you want to learn from our experts live, then you can call on the given number or you can fill the form that is provided in our description. Not just that, with our every batch, you will be getting 2 demo classes for free.
First of all, guys, to call any module in our program, all you need to do is use this term called as import. Import allows us to import that module inside our program. So first of all, we are talking about date time. So I'll be writing date time. That import date time. So nextly, if I want to know a date time of right now, like what is today's date, what is the time right now. So all I need to do is create a variable a is equals to date time dot date time and dot now. So I want to know what's the date and time now. So I'll write it in this way, and if I print it and run my program, you will see we will be getting so many parameters over here. First of all, we are getting the year, that it's 2022. The month is March and the date is 22. The time right now is 12 in the afternoon, 12:38, 51, 38 over here are the minutes, 51 is the seconds, and 0.358330 are the microseconds over here. So this is how the date time module provides us with the output. Okay, date time module also allows us to create a date of a particular time. Like for example, if I write a is equals to date time dot date time. So guys, date time takes three parameters over here. First of all, it takes the year. So I'll be talking about, let's say, 1997. It takes the month, so the 10th month, that is the October, and the date over here, that is, let's say, 14. So I'll be adding 3 parameters over here, and if I print it, I get output like this, that we are talking about 1997 October 14. Okay. Now there is another object over here that is used, or that is widely used in date and time, which has many applications also. That is called as strift time. So let's see how strift time can be used. So if I write over here print a dot strftime strift time, and I'll provide it with a parameter over here. That is, let's say, first of all, so strift time has many parameters over here. It takes a lot of values. I will be discussing about all of them one by one. So first of all, we have percentage or modulus small a. Let's see what modulus small a will do here. It will provide me with the TUE that on 1997, that on October 14th of 1997, it was a Tuesday. If I write capital A over here, let's see what it does. It gives us a Tuesday in a full form. So small a was giving us in a short form, while capital A will give us in a full form. At the same time, if I use over here capital B, it provides me with the month of that particular date. Similarly, if I write capital Y over here, provides me with the year, that it was 1997. If I'm talking about a particular minute or seconds also, we have that options also available with us. Just like modulus Y, we have modulus P, which provides us with the AM and PM of a particular time. We have modulus M, which gives us a minutes of a particular time. We have seconds. For seconds, we have capital S. And for microseconds, we have capital F. Similarly, we have so many small keywords that we can use with the strift time. So I'll have enlisted like 3 or 4 of them, but yes, you can definitely try more of them. So, so I hope guys, what is this date time module is clear to you, and how you can get a date time of a particular time, and different applications with the strict time is also, I hope, clear to you. Moving ahead to our next module, we have random with us. Random. As I told you, random allow us to randomly fetch between the values. So let's see how random can be used. For again importing random module, all I need to do is write import random. After writing import random, all you can do is you can take a variable. Let's say a is equals to random dot random int. I'll be taking random integer, any random integer from 1 to 10. I don't want to pick any particular one of it. I want it to be random, that it should be any random integer between 1 to 10. So I'll be writing 1 comma 10 over here, and if I print it, if I write print a over here and run my program, you will see it gives me 9. If I run it again, it gives me 10, 8, 10, 5, 4. So every time it is giving me a random integer. It's not giving me any specific integer every time. It's randomly giving me the output. That's what random basically do. So for example, if you want to create a dice roll program with the help of a random module, then all you need to do is take a is equals to random dot random int from 1 to 6, and you can say the dice roll would be, let's say, 6, 5, 5, 2, 2, 4. Now these are about the integers, that when you want to pick a random integer, what if you want to pick between the terms over there? So all you can do is you can use list as well over here. How to do that is, suppose if I have written list of, let's say I'm creating two variables over here for heads and tails. So I'll be writing coin is equals to, I'm creating a list with two values, heads, comma, tails. Right. Now what I need to do, I need this A to randomly choose between heads and tails. So what I'll do this time, instead of taking random dot random integer, I'll be taking random dot choice. So random dot choice, and that choice will be from the coin. Okay. As soon as I run it, it gives me the output tails. If I run it, it gives me heads. Heads again. Tails. Tails. Heads. Tails. Tails. So as you can see, every time it's giving me a random different output. So yes, this is how a random module can be used. Moving ahead to our next module that we have in Python is a very useful module, that is our math module. So to import math module, all you need to do is write import math. Now math has many applications with the help of math. Inside the math also there are so many objects that can be used. So we'll be discussing some important of them one by one. So first of all, let's talk about the minimum and maximum in math. For that, all I need to do is create a variable. Let's say I'm creating a variable a is equals to minimum, and I'll be taking 3 parameters or 4 or choices, totally up to you that how many parameters you want to take. So I'll be taking 3 numbers, 35, comma 2. So we clearly know that the number which is the lowest number over here is 2, but still if I write print a over here and run this program, it gives me the output that the minimum value over here is 2. Similarly, it works the same way for the maximum, that if I write x is equals to max, and I'll use the same thing over here, 10, 35, 2, and provided with, and I'll be writing print x over here, and as soon as I run it, I get the output 35, that the maximum value over here between these 3 numbers that has been provided is 35. Next object that we have over here is power. We can use, we can use exponent to fetch the powers, but math also provides us with a function where we can get the power of any number. So all you need to do is write a is equals to POW. POW will be the short form over here for the power. And we can provide it with a number, that 3 raised to the power 4. And if I print a, I get the output over here, 81. This is how power can be used. If you want to check with a small number, x is equals to POW. And I'll say 2 raised to the power 2. So 2, 2. And if I write print x and run it, it gives me the output 4 over here. Right? Moving ahead, next we have absolute. Absolute provides us with absolute positive of any number. For example, if I write a is equals to minus 12, and in front if I write absolute of it, and then if I print a, and run it. It gives me a positive of 12. At the same time, if it was a decimal number, let's say 12.12, I would have written it and would have get the output in positive, that is 12.12. So absolute here does nothing but gives us a positive of any expression that we have provided. Moving ahead, next we have in our math module is square root. So yes, square root we can also find a square root of a number by using a small word over here, that is sqrt. All you need to do is write a variable a is equals to math dot sqrt, and here square root of whose square root you want to find out. Let's say I want to find the square root of number 49, and if I print it, I get the output 7 over here. That 7 is the square root of 49. Similarly, if I go with 64 over here, it gives me 8. If I go with 125 over here, it gives me 11.180 or something. So you can basically get the square root of any number by using this small trick over here, that you import math, use math.sqrt, and then followed by a number whose square root you want to find out. Next we have with pi. So math also allows us to find the values with the pi. So all you need to do is write a dot math pi, and if I run it, it gives me the value that 3.14. Generally, when we do it with our hands, we take 3.1. Here for the proper calculation, it gives us the whole number. So yes, math.pi also works over here, and you can write any expression after this. Suppose if you want to find the area of circle, so math.pi times, let's say, radius square. So let's say radius is 5, and 5 square I'll be writing over here. So I'll get it as 78.53 and so on. So this will give us the actual multiplication because it takes the actual value of pi over here. So guys, to understand our next method in math, I'll be just taking one small example. So let's say I'm taking two numbers over here, 8 when divided by 3. So we know that twice of it gives us 6, and the remainder comes 2. Then we need to add a decimal over here, which gives us 20, and here it becomes 18, and it becomes 20 again, and it keeps going on in this way, right? So division gives us this quotient, that 2.66, but if we talk about the floor division, it gives us a previous closest value, that is, let's say 2 over here, right? So what if I want to receive a greater value? Suppose if for 2.66 over here, if I want to receive 3, we have a method here in math module with which we can receive 3. Let's see how it can be done. So if I create a variable over here, a is equals to math.seal of let's say 2.66, and at the same time if I write b is equals to math dot floor of 2.66 again. Let's print them. Print A and print B, and now let's run and see what happens if we run this program. So you will see that the seal will give us the next closest value, that the greater closest value, while the floor will give us the lesser closest value, that is the previous closer value. So for 2.6, seal is providing us with the 3, while at the same time floor is providing us with the previous closest value. So guys, this was our seal and floor, and these were some of the main methods that we have learned in the math module of Python. So guys, these were the 3 inbuilt modules that we have discussed briefly. First is date time, second is random, third is math. And I hope you guys have no doubts and no questions in how these 3 modules can be used and what are the many applications of these 3 modules. And in our next session, we will be learning how we can create these modules. So far we know that how we can use the inbuilt module and call it in our program. But now in our next session, we will be discussing how to create these modules and then use it in our program. So stay connected guys, and I'll see you in the next session. Thank you.